Okay, let's continue with unit ramp. So unit ramp is defined as RT. Okay, simply because we want to distinguish between UT and RT. So UT is unit step, RT is unit ramp. Okay, so it's still using piecewise function. So we have T, function of T for T more than 0. So we have T, okay, RT equals T for T more than 0. But we have function of 0 for T less than 0. Okay, for T equals 0, for T less than 0, the RT is 0. So this is the unit ramp. And also the unit ramp is the integral of the unit step. Okay, never mind, we don't use this, right? Next is exponential signal. Okay, so exponential signal is given by xt equals e sigma t, exponential sigma t, right? Exponential sigma t. So the sigma is the cross at y-axis. So here if it's the function cross at 1, so is e1t. Alright, if it's cross at 2, then e2t. Alright, so if the t is negative, then the slope is in negative. Alright, so e still 1 minus t, then the slope is like this, and it will not touch the value. Okay, it will not touch 0, sorry, not touch the axis, the x-axis. Right, exponential decay, exponential growth, exponential growth, exponential decay, right? Okay, next is extractive part of another signal. For example, the piecewise defined signal. Alright, so we have exponential of minus t for t more than 0. So exponential minus t is this, right? I think I made a mistake before. Alright, sorry, my mistake. I said before that the sigma is cross at y, so that is wrong. Okay, actually the value in front here, if this is 1, this is 1. Okay, if this is 2, this is 2. Okay, so the sigma here is actually depends on the value crossing here depends on the sigma. Right, if the sigma is negative value, then it is a exponential decay. If the sigma is positive value, it is exponential growth, right? So the crossing at y-axis represented by the value in front here. Alright, so okay, in this case 1 and 1 here, right? Okay, so 1 e minus t, this is the graph. But if we have this piecewise function, it will look like this. For t less than 0, it is 0. For t more than 0, it is the exponential decay. Alright, so this or this can be written as this. right? So how can we get this? So if you look closely, this is actually combination of two signals. Alright, this is a combination of two signals. Ut is the unit step function, if you still remember. Ut is the unit step function, and then the exponential negative t, that is the exponential decay. So you have two functions, ut and exponential negative t. You multiply these two, then you will get this, right? So let me just quickly draw so you can see. This is the exponential decay, all right, and this is the unit step or ut, the ut here, ut, right? So this is ut, this is the exponential. So when we have multiplication here actually, right? Multiplication. So ut multiply with e negative t, will get this. How? Because this is 0. So anything multiply with 0 will get 0. And this is 1. So anything we multiply with 1 will get this value. Right? So that's why it says can also be written as this. Right? That's the idea. Okay, next example, another example. We have ut, so meaning that for t less than 0, okay, t less than 0, it is 0. That's what it means. So it's 0. Then we have 2 exponential negative 2 over negative t minus, oh sorry, negative t over 2, right? So the 2 here is the cross section at y-axis, and then we have negative t over 2. So that one you really don't have to bother. Okay, you just sketch the exponential decay. All right, as long as you get this correct, it's good enough. All right. Okay, next is sinusoidal signal. So the period of the sinus is the t equals 1 over f, or equals to 2 pi over omega with the unit of second. Okay, of course the unit is in second. This is the t. The phase of phase angle of the signal is theta, given in radians. Okay, so that is just to recall, because you can also write this in piecewise function. Okay, next is unit impulse signals. So impulse is just a single value at a single time. Okay, see here we have step before, so this is the impulse. Okay, single value at a single time, right, like this. So it can be written as delta n. Okay, in which for n other than 0, it is 0, but for n equals to 0, it is 1. So the value is only 1 is at n equals 0, right? So here at n equals 0, 1. Other n value than that is 0. Okay,